So, welcome back, everybody. I hope you're not too much asleep after that lunch. So, I will present you what has been updated in the type-safe event specification of OSGi. So, it's currently a draft. It's a 1.1 version, and it should be released in the R9, hopefully. So a bit about myself. So I'm Thomas Calment. Well, not most of you now, but the first time I did a talk here at EclipseCon was about bringing OSGi to Python. Someone has that dumb idea, let's say. And I now work for Kentio, which is an Eclipse sensiNact supporter and committer. I will show you a bit more what sensiNact is and how we use it and how we use typed event in there. So a word about Kentio. So we have a stack with well-known names. So what we have, in fact, is something to aggregate data from multiple sensors. And mainly sensors which have totally different protocols to work with. And we want to push that to the Kent UI, so the UI we show to the people we want, and a bit of AI to do forecasts, predictions, etc. So you have some examples of use cases we have above. So, for example, checking presence of persons in a park, checking the saturation of intersections, and even safety on intersections, trying to understand if a car and a pedestrian will hit each other at some place in the intersection. So for everything, at the core, we have Eclipse sensiNact based on OSGi. So let's talk about type-safe events 1.0. So I suppose you know about event admin. So the idea is to send messages over a topic, and you send everything, anything you want in the event. So it's good, but how do we make that type safe? Because internally in a gateway like sensiNact, for example, we must be sure that what we get is valid content. Also, how to know if somebody is listening. That's something you don't know in event admin. And yeah, that's what a type-safe event was made of. So we use the DTOs, so the data transfer objects, or DTO-like objects. And everything we pass with the topic is sent to a typed event bus. So like we discussed a bit, the current reference implementation is Apache RES, a typed event bus. So it's passed with a topic, and they are received by listeners that are detected directly. Listeners are registered with the list of topics they want to listen to, and they are supposed to know which type they are expected to get. Event data is converted, so it's really using the OSGi converter specification to get from any input they had to the data we want in the listener. An interesting thing is that we have an unhandled event handler. So if you send an event and nobody's there, you can register an unhandled event, and it will tell you that message was received by nobody, and you can react to that. So either you stop a subscription, or you can debug your software and see why that doesn't work. And the main thing of the update is about that. In 1.0, the wildcard filter was used always at the final part of the topic, so like in MQTT. So you could have, for example, a data / wildcard to get all the topics that matches that. So to monitor events, you had that method. So you get a stream, and that's where you can watch everything. And there is also a small talk about number of events. So the important thing here is that it's optional, and well, not a lot of specification we saw had it. RES has one that works on the number of events that were received. So how do we use it in sensiNact? So here is the usual diagram we use to present sensiNact, at least in our case. So sensiNact, you have a core that keeps track of, well, we use the term digital twin, but it's mainly, we have an internal model of a set of resources, and we keep track of their value and when they were updated. So that's a big overview. You can access it via different northbound adapters, so it could be HTTP, WebSockets, as we will see soon. Or any other thing. And southbound, we have the different protocol adapters that will get the data one way or another. And in the northbound, we can access data using different verbs. So having a description of what it is, so what type of value is there, get to get the value, set to set it, and act if it's a method, for example, release a magnet or something like that, you would call act on that case. But we also have two other verbs, subscribe and unsubscribe, where you are listening directly to notifications saying the light went on or the temperature changed since the last time. And that's where typed events are important for us. Every time we have an update of a resource value, so for example, the temperature, we'll have, in fact, this a message on this topic in typed event with a specific DTO that tell us the previous value, the new one, and the whole path to the resource in question. So here you have the model of sensiNact. So model describes what's a Raspberry Pi with such sensor, for example. Provider is the identifier of the Raspberry Pi that Guido showed us before, for example. Service is a group of resources, and resource holds the value we want. So like I said, if we have the Raspberry Pi that says we have a new temperature of 35 degrees, you would have an event there. And what we want, oftentimes, is to get all temperatures of all the sensors we have in a room, for example. But the issue with the current typed event, type-safe event topic filter, is that our filter will be quite high, so quite high level in the topic. So for example, here in model, we can say, I want all Raspberry Pis that have a temperature and humidity sensor, but we'll have to filter by ourselves what's behind. We don't care about humidity, we don't care about the uptime, etc. Also, the issue is for sensors that send data not that often. For example, at some point we had a sensor that was telling us when car parking state change. Is there a car on it or not? And it was just an event that was sent. So if you subscribe to it and the car doesn't move for 3 days, you won't have any updates on it, and you don't know the current status. So that was an issue there, and that's why we need to have the history and to indicate how many values we want to keep. And so is one event sufficient, 3 events, etc. So that's something that we want to know, be able to configure. But first, back to the topics. So that I explained to you. So now we are working a bit more like MQTT again. So in MQTT, it's a wildcard. It's a sharp symbol, like in C#, for the wildcard. And the plus means in the path, I allow any value in that section. So for example, here, I don't care about the provider name, if you remember the topic I showed earlier. So we want any data from a Raspberry Pi that has a temperature sensor. I don't care about which Raspberry Pi, but I want its sensor temperature value. And now I don't have to filter anything. I just have to get value inside. I can extract the source from the DTO I get, from the complex update object I get. And I have everything I need. So our code went from 10 lines of filtering to just 1 line. I want to update that or send the update somewhere else. So for example, here, that's one intersection we have in New York that we monitor. So you have the raw video. We have an object detector that is out of the scope of sensiNact, but we get an MQTT update here that gives us all the position of the boxes, etc. So the idea is to have, it's for privacy concerns. In fact, on our end, in sensiNact, as we have only the boxes, we don't know which car it is. We don't know, we can't recognize someone. We just have the important information to detect if there will be a collision or not. And for that, so we get it from MQTT, and then when we want to push it to our UI and to monitor alerts and then feed them back to the intersection, we in fact now just have to filter those two topics, and that's all. We don't have anything else to do. We just know it's a traffic thing. We will get the provider from the message. We have the position and speed of the various types of detected items, so a car and a pedestrian mostly. Yeah, it's quite easy now to do that and quite effective because now we only get the events matching that event. So if we don't activate that feature, no events will be sent. And here we don't care, for example, about the azimuth or the quality of detection, etc., because that's not in our use case. So it removes a lot of unused events. Also, we could have multiple filters saying we want cars and trucks, but no pedestrian, this kind of stuff. That would reduce every time the number of events we want to get. So regarding the history, now what we have is an event history service property that will allow us to know how many events are stored in memory. So the default value in RES is 124 history events. If you put it to 0, obviously that property to 0, you won't have any history set up. Yeah, the issue is you have to know how to configure it depending on both your need of history and the size it will take in memory, obviously. Well, I recommend you to not put a gigabyte of data in a DTO because that's not made for that at first. And so when you subscribe to a topic that has a history, you will get, for example, if you have a history of 5 events, you will get the 5 events at once in the same order as they were stored, they were emitted. Also, there is a new method that requests only history, so that doesn't care about having a push stream with everything, but just to have what is currently in history.
There's a question.
Yeah.
I was wondering if you had use cases for a history of greater than 1 for this kind of service.
So that's for a more generic use case. If you want to see the evolution, for example, of in the case of a temperature sensor, you could have, let's say, 100 temperatures to see how did it evolve in the whole day.
I mean, you could, but there are other mechanisms.
Yeah, sure.
Right?
Yeah.
So I understand the one, because if you're a late sign-on, you want to know what the present state is, but other than that, I haven't seen personally a use case for more than one.
Yeah. So that's where the disclaimer comes in. You will see that with the WebSocket talk after James's talk. Those slides were made by Tim Ward, our colleague, that couldn't be there for happy reasons. And he's the one behind the current draft of the typed event specification. So I'm mostly a user. And yeah, like I said, I can see that for a temperature variation or this kind of stuff. But yeah, he didn't have time to tell me what he had in mind writing that. And nearly final slide. So now we have the publisher. So in fact, Stefan presented it a bit this morning. So the typed event publisher is a way to say I will send my events always on the same topic with the same type of events. And the idea is that you don't have to check the validity of your topic every time you send data, because it's not a long check, but yeah, it takes some time. You have to parse it to verify that everything works. So with the publisher, you do it at the creation of the object, and then you just emit events as you wish. So I have a demo. So that's demo time. Let's see if it works. So what I have is a web browser somewhere. Tech. Yeah. No. Ah. No. Okay. Let's do that. Better. So here, with the network error, obviously, demo time. Okay. Yes. So it's not real data. Don't buy options at NASDAQ with that. So here, in fact, we have something that produces events every second and pushes them to us via a typed event. So here, the topics are in the format stocks slash the country where the index is registered, the stock exchange place, and the value ID. Plus, in the data, we have the new price of the action. So what I can do is to configure it here, and we can try our new filters. So for example, now I just want something that is anywhere, and that has the GSQ name, for example. Tac. Add that one, remove the general one, and we save. So the fact that the configuration has been updated is itself another typed event with another type, which gives us a new configuration. And now we will only get events from that match the current pattern. So here, our GSK action is available in New York and London. So the plus removes the issues, like I said, of having filters inside. Let me find the right here. So the country and the place where it's quoted. And here, what you see is the unhandled event handler. So we are aware that all those messages are listened by nobody, which is logical because on the other hand, the UI only looks for GSK data. And if I go back with my usual stock, if I didn't mistake, we get back everything immediately. So now, what happens if I stop my listener? I get no messages. I still have the information that my events are not received because I don't have a listener on the server side. And I don't have a history. So here, if I just re-register the listener, I get my messages, and I lost a lot of messages. So now what I can do is just say, I have a history of 10 values, stop the listener, configuration is updated. We can see that the events are still appearing. And when I set the listener back up, it will get a batch of messages. Here you can see we received all the messages at once, and now we continue to listen to it, to that events. And here we don't have any complaints about having unhandled events because we listen to them all. Okay, it was a bit faster than I expected. So, do you have any questions that I can answer? So, first one, and then maybe. Who's first?
Just a short question about the history. Is it topic or generic? Topic-based or generic?
So the history is generic, but the events you get match the topic you registered. So that's a discussion we had with James just before the talk, and yeah, that's something we have to update in the specification, I think.
So towards topic.
Yeah, that would be a better thing because, for example, in the use case I showed with cars, etc. Even if in that one we don't use history because it's updated too often. But if we wanted to have history, yeah, in memory we would add events that are stored, whereas we never use them. Yeah. So yeah, that's an upgrade to prepare. Yeah.
Okay. There's a slight inconsistency when we use history because maybe that events previously marked are not received by anybody, and then later time received, and afterward it's not true that they are not received.
Yeah, it's not true anymore. Yeah, and yeah, that's something I didn't think about. Well, I would say the solution would be to say afterwards, okay, it was finally received, so enhance the unhandled event history, but yeah, we still have to find a use case on that one also, yeah. But I see the point, yeah.
Just a question to your use case here.
Yep.
Why do you speed up velocity? Because if you're doing collision detection, you need to know velocity. Velocity, you might want to actually know acceleration as well.
Yeah, so, well, currently what we do is, because the first issue was to compute the speed of the car based on the perspective of the camera. So that was the first thing. And currently what we are trying to do is to compute a predicted trajectory, but at the AI level. So at the detection level, so that instead of getting position and speed, we would get current position and estimated trajectory.
Okay.
So that's just a temporary, yeah.
If you can get speed, you can get velocity. You can even get acceleration, because if you look at the last couple of frames, right? You get those information, you get much better
Yeah, sure.
collision detection, and,
Yeah.
and I'm not sure it's better than any other kind of way of predicting where the car's going to be in the next, seconds.
But here the idea was really to have to have something to display there, and also speed. You will also use it for how to say that, have kind of a speed trap based on video.
Okay.
But yeah, it's not. That's part of the because it's how to say it. It's a research project from the University of Columbia in New York, and that's part of the exploration work of what they could do with 2 cameras, because here we see only one, but they try to combine multiple cameras to have a 3D, to have a better view of the intersection, because here, for example, the left part is totally obstructed. So you have a camera that looks at that angle, and they put everything together to have a better view of what happens.
I can give a bit more information about the context. There are actually 3 cameras. One on the kind of bird eye view camera on the 12th floor, and 2 cameras, one on the 2nd floor, which is this one, and another one on the 1st floor, which is in the street at left.
Yeah.
So there are 2 groups working on the, us 3, but on the Columbia case. So one is indeed integrating cameras on the 2nd floor and 1st floor view to have a more accurate detection, and another one on the 12th floor camera, which is this bird eye view, which is quite accurate in terms of speed, because you don't have this depth that you have to deal with, because it's on the top. It's easier to calculate the speed and acceleration for sure.
Right.
And the idea is indeed to have a kind of an index of dangerosity of the intersection. So count of vehicles that overpasses the speed limit, or overpassing the red light, and also having these dangerous situations, seeing that a vehicle approaches to a pedestrian walking area, and at the end the ultimate action will be to warn pedestrians and the vehicles with some actuators, either installed on the sidewalk or on board in the vehicles.
Yeah.
So, and having all these, maybe some sub-gigahertz communication facilities, or 5 or 6G, all these, somehow the next steps that we are planning.
No, I just wondered, because, if you have speed, if you can detect speed, you can you can detect velocity as well, and it gives you a finer-grained way of doing collision detection without much more.
Yeah, sure. Yeah, this is a bit real demo.
Yeah.
Real-time information.
So it receives as if it was a real time. Well, it stutters a bit due to either network connection or how it's sent as its replay data. But yeah, everything here, in fact, is sent as an event inside sensiNact. So each frame is given as an event, as multiple events, in fact. And here, I think, here we only have 2 categories of so usually that's a bus.
This is a big truck that turns.
It's a bus, turning there.
And the bounding box becomes like.
Yeah, that's a bit of the issue with bonded boxes. And so here, for example, in the filter, we only get pedestrians and vehicles. And in the events we don't care about, for example, we have the split between vehicle, car, truck, and bus. And same for pedestrians that are, if I remember correctly, bicycles are also considered pedestrians here, in that use case. No, doesn't want to stop? Well, okay. Yeah.
I have more of a question about the type event thing, because I don't think I understand the implications on dependencies between mounts. So from what I understand, you're implementing as a listener something that is an instance of type event listener, I guess, and you also told the publisher some type of type event publisher, right? And both of these obviously have as a generic type some kind of DTO. But
Yep.
that doesn't have to be the same class, right? Because there's a
Yeah.
fire together.
Yeah, so you have to have something that is convertible from one to another. So for example, you could say, instead of DTOs, I want to listen to integers, let's say. And if I push an event which is a string, the converter will do the conversion from my data to the one you want. But they're supposed to be convertible one to another using the OSGi converter service.
If I'm listening to events and I'm specifying a type, does it have to be a 100% match? For example, if I had an event that has like, I don't know, 5 properties, and I as a listener only care about 2 of them, and only those 2 are filled with my DTO, would that still work? And all the events would maybe...
So for that one, I'm not sure it would work because unless you register a custom converter, maybe.
I'm not sure. I believe, if I remember the spec correctly, this was one of the intentions to also filter things automatically
Yeah.
in that regard, so that you can have smaller DTOs than what you would actually get. But don't
Yeah, that.
nail me down on that.
Didn't the spec also mention that the DTO class should belong to the subscriber and the sender in the same way, so it should be the same basically.
I'm not an expert in the converter because how we use it here in sensiNact, we always have the same type. We send A, we get B. We get A directly. We don't try to have a conversion in between.
So I will have to read the spec again.
Yeah, I think everybody has to read this. Also, it's a draft, so.
The type could have been an additional filter.
That could be a filter, yeah. But then you have to decide what you do if it's not a 100% match. Do you accept it and convert with a subset of the properties, or do you reject it directly? Yeah. A lot of discussions to have about that spec.
Join the spec meetings. Okay.
Okay.
Thank you, Thomas.
It's James after all.
You're up.